Hello again. In this video, I'll be going over the standard deviation. So the standard deviation is a bit more mathematically complex. And so I think once again, the most effective way to describe it would be by taking an example. So let's say we have a data set with the first 5 numbers, 1, 2, 3, 4, and 5. So if you really want it, the formula for the standard deviation is the square root of the sum of all the squares of each value minus the mean of the data set, all divided by the number of values in the data set minus 1. So I know the equation looks a bit scary. So for this data set, for example, we can figure out that the mean for the data set is 3. And so the standard deviation would be 1 minus 3 squared, so negative 2 squared, plus 2 minus 3 squared, so negative 1 squared, plus 3 minus 3 squared, 0 squared, plus 1 squared, plus 2 squared. All divided by 5 minus 1. So if you were to compute this, it would become 4 plus 1 plus 0 plus 1 plus 4 all over 4, which is square root of 10 over 4, which approximately comes out to 1.6. So, we did all of this calculation, and you may be wondering, what does this mean, right? So the standard deviation, if you know calculus, it's basically the inflection point. If you were to make a bell chart of, a bell curve of this data set, it's where, from the middle, the equation becomes from negative acceleration to positive acceleration. But if you don't know calculus, in simpler terms, it tells you how close together or far apart it is. So, we use the mean in this calculation, and when you're doing the standard deviation, the mean will be the center of your data set. But, having a center doesn't really mean much if you don't know how far apart all the data is. So if it's really spread out, it may be harder to run analytics on it. So the standard deviation is basically a measure of how close together or far apart all your data is surrounding the mean. Thank you for that. And in this next video, you'll understand how to implement it programmatically.